Okay, so welcome everyone. Mark Nelson is an assistant professor at American University and has held a few other positions before that. You are familiar with Mark's work from the declarative optimization-based drama management, but he's also done work in several other areas and has some upcoming work on drama management that he's hopefully going to talk about today. So with no further ado, I'm pleased to introduce Dr. Mark Nelson. Take it away.
Thank you. I have a little presentation for the beginning part, so I'll just share that. Does this share still work after I hit play and went full screen?
We can see your slides. Does that answer the question?
Yes, that's all I was wondering.
Great.
Okay, so I'm going to talk a little bit about search-based drama management, which you've read one of the papers on, Stephen told me. And this is work I mostly did around 2005 through 2010, kind of my dissertation, different direction, looking at generating game mechanics and things like that. I'm kind of interested in authoring tools of various kinds. And I've started looking recently with some chats with Michael Matias also, who was my supervisor, on kind of like, what did we learn from this? What are open questions? Is there like, what could either be built on it? Is there something scientifically testable? And so I have kind of a hypothesis about what is really implied by, or what is really implied by this line of work, I guess, like what needs to be true for this to be a reasonable way of building interactive story systems. And I'll discuss a little bit of that towards the end. I'll just kind of go through some of my thoughts on how this works. You've read one of the papers, but I'll sort of summarize some of the systems. You can also feel free to ask me questions during the presentation if something comes up. Otherwise, we can chat at the end. And so the general formalism here, I've used different terms over time. It was originally called search-based management, and I kind of didn't like the implication that only search could be used, because you can also use reinforcement or anything else that can do game kind of playing. And so I called it declarative optimization-based drama management, but that is an even bigger mouthful, so I've gone back to using the two interchangeably. But basically the formalism is story as a sequence of plot points. A drama manager has these discrete interaction methods, like saying, close this door, or hey, hint to the player that this thing they have not noticed yet actually exists. And then there's an experience quality function which rates finished experiences. It runs after an experience is completely done, and it says on some kind of numerical score, how good was it? And the DM's job is to figure out how to use these DM interventions to maximize experience quality. This is a kind of graphical overview of that. There'll be some sequence of plot points and DM actions that have happened so far. And the DM then is given a choice point saying, this plot point just happened. Do you want to take one of these 4 actions, of which no up? So do nothing is always an action, is a possible action. In the search-based method, checks possible features. What if I took this? What if the player then did this? Until it gets to a end of game or end of story, and then runs the evaluation function. And using kind of like a standard game tree search, it then picks the action with the highest expected outcome. There's various things you could plug into this. You could have a player model in here. You could assume some kind of distribution based on past empirical data collection. I'll discuss that a little bit. And also, it doesn't have to be literally online search like this. You could run something like reinforcement learning with the same conceptually searching in policy space, but not online search during the game. And the world interaction is kind of a key part of plugging this into a real game, and was initially one of the things we saw as a positive about it, that it doesn't require, unlike my advisor was Michael Matias, and he's at this time was better known for Facade, which just came out in 2005, and was this a completely custom game engine based on a reactive programming language Able with a custom like procedural animation system, and got pretty good results, but really required you to like buy fully into it. So like this game was made, Facade was like made completely with specific technologies. The hope with this search-based drama management is that you could plug it into games mostly authored in some more regular way, and there's these discrete communication points. The game signals to the engine, for example, in one of our implementations over just like a socket. that, hey, this action happened, and it gets back a response. And there needs to be a little bit of glue logic in the game to both signal and interpret the responses. But you don't necessarily have to kind of like completely change from regular authoring methods. And in fact, the example here is from an interactive story called Anchorhead that won an IF award, and the author was kind enough to share the source code with us. It was written in Form 6, which is a popular interactive fiction text adventure authoring language. Now in Form 7 is the current version, but that was the case at the time. And I started kind of going through writing little bits of code. It seemed like there were important story points that would signal over like a network socket to the drama manager, which was written in Java. These discrete things like the player asked the bum about Anna, which was one of the possible branching story type of things that the player could type in. And this has some prerequisites. It can only happen in certain cases. It has a location, and it's part of like some kind of subplot. So this is all annotated by the person creating the DM into the game, which was me in this case. And the DM can signal in response, hey, make sure the bum brings up the crypt. Why? So this is kind of because it seems to produce a higher overall story. And this is kind of the decisions the DM makes. Should we bring something up now or not? And the effects of DM actions are also annotated by the integrator. So me in this case saying, when the bum brings this up, it will cause a particular plot point to happen. There are other things like denies that could prevent something from happening. And there's more probabilistic ones. Like if you hint something to the player, it doesn't necessarily mean they will do a particular plot point next, but it might increase the probability of it. It also has some kind of attached manipulativity score, which will be used the evaluation function to kind of prefer fewer options, especially those that might be noticed by the player as too much of puppets sort of behind the scene pulling strings.
Yeah, Mark, could I ask a question?
Yeah.
That was one of the things that sort of came up in our discussion was the DODM paper we read, and it also includes the sort of follow-up work by David Roberts and Charles Isbell on the using reinforcement learning, and you sort of brought that up as well. What is the source of non-determinism? Like, do you make any assumptions about which action, like are all drama manager actions considered deterministic? Are all player actions considered non-deterministic? Like, can you just talk a little bit about that?
Yeah. DM actions, this particular DM action is deterministic. If we take it, it will definitely cause this plot point to happen next. There are ones that are more non-deterministic, which just increase the probability of a plot point happening next. The main source of non-determinism, though, is uncertainty about what the player is going to do. In a lot of work, we just assume of the possible actions that plot points that could happen next, just a uniform distribution, because we have no particular knowledge. There's been some work that tries to, and that's obviously just a starting point. There's been some work that tries to build a slightly better model. So Anne Sullivan did some work that was in a 2D kind of graphical environment, and they used basically some measure of path planning distance to be what's most likely. If a plot point has all its prerequisites fulfilled, so like the room is unlocked and the item is there, then it uses distance from the player's current location as a measure of likelihood for what's going to come next. You could also empirically collect data about what players actually do. We have not done that, or build some kind of, there's like a whole sub area of player modeling, which could be useful to integrate here.
Sure, yeah, but that answers the question. So there's at least two sources of non-determinism, which is not all DM actions have a deterministic result, and then we assume that we don't make any particular assumptions about what the player will do. Even if we have a non-uniform distribution, there's still sort of no guarantees about what the player will do. So we still treat the player moves as non-deterministic, right?
Yeah, we treat the player as some kind of unknown but probabilistic entity. And some of the DM actions basically change that distribution. We'd say without any intervention, the player is equally likely to do these two things because they're the same distance. But we really dropped a strong hint, so we now think this one is 3 times as likely as before, or something like that. And getting those numbers right would have to be validated with player studies. And I mentioned briefly kind of this prerequisites. This is the main way without any kind of player model, the DM knows what could possibly follow what, in that actions have prerequisites. And this gives it at least some information that, for example, See Evil God is one of the endings. and it has two prerequisites. If neither of them have been fulfilled, it's not likely to happen next. So if it didn't want it to happen next, for example, it doesn't have to worry as much, or it could try to prevent it by preventing one of its prerequisites. This is an and/or graph. It's borrowed from Peter Weyrauch introduced this particular way of modeling plots, at least in drama management work, as far as I know. You read it is anything with no incoming arrows. So the four things at the top could just happen without any prerequisites. Any incoming error is a prerequisite with an and implication. So for example, the left open safe can only happen after the player has both discovered the safe and gotten the safe combo. Unless there's a little or annotation, which you can see at the bottom right, there's three possible inputs there, and it can happen if any of those three happen. So this just kind of legal plot sequences or any possible ordering of this, like walk through this graph that respects requisites. And this has to be written by the person integrating with the game. So the pro and con of this approach is you can hook it into some arbitrarily complicated like C++ program or something written in Inform or whatever crazy language you want. And the DM doesn't need to know about that language, but it needs to be given this kind of like abstracted view of what are the possible sequences through this world. And so this is an example of plugging it into Ink. I took the original source code and I just kind of looked through where important things happen. So when the player opens the puzzle box, there was already some code in here, and I just wrote like another line of code that calls out to this network socket and sends, hey, open puzzle box happened to the drama manager. It then pauses a bit before drawing the next line and waits for a DM reply. And the DM here, what would normally happen in the originally written story is the player would then get the amulet. Or could ask for the amulet, but the drama manager here sent back temp deny get amulet, which means the player temporarily cannot get the amulet until I re-enable it. And then it will respond with, he just puts it back. And if you ask for the amulet, he just picks it up saying, nice, isn't it? And doesn't give it back to you. And so the work that had to be done to integrate this is the first one is a little bit easy, signaling open puzzle box. You just have to identify plot points in the story and send these signals. Implementing the responses is a little more difficult because this requires me to write new text, in this case, hopefully in the style of Michael Gentry, who's like an award-winning interactive fiction author, which I am not. And the more actions, the more kind of combinatorial possibilities you might have to deal with. So if two different things are denied at the same time, in Inform, I basically have to be checking these different Boolean variables and produce different outputs in response. The original proposal, well, actually, I'll get to that in a second. So this was originally part of a bigger project, the Oz project, which I believe you've also read some about. And the original idea was that there would be some kind of more smart text adventure world where you could send high-level commands and it would figure out how to implement them. Like, hey, hint to the player this, and it will then have some subsystem that figures out, okay, which NPC is nearest the player, who can more reasonably bring this up. But the games I've either implemented it into or seen implemented are written in much more conventional, like just code style. So we don't have some kind of smart world to send these commands to. So here's a different example. This was a game where Anne Sullivan led the development called Empath, and this is a 2D top-down game and uses locations a lot more than kind of, if you think of like where the player is in this kind of game, there is a narrative state, but the physical state is also very important. In Anchorhead, the narrative state is really the majority of it. There's only a handful of locations, but there's a lot of kind of like, it's a very long story with a lot of different subplots. And so here, there's a little code that runs, if this person says help and the player is within some distance, it triggers the here cry for help plot point. And in this case, the drama manager closes a different door where the player would have gotten a note hinting at where the prisoner is located because they've already found the prisoner in this case. And so we consider that to be sort of a red herring that the player shouldn't. I mean, I'm kind of explaining what the DM does here. What it actually does is it does some big search of the possibilities, but I'm guessing that's the reason it chose this in this case. And so a little bit of the context of this is Joe Bates proposed this in 1992 in this article, Virtual Reality, Art and Entertainment, which was only a 6-page paper, but has kind of some of his big vision for interactive storytelling. It's interesting, it was in a VR journal and has this title, but is really about interactive story. And as far as I can tell, not VR at all. It's just VR was kind of hot in 1992, as it is now again, and so he kind of rode that wave a little bit. I mean, he might have had plans for it to be in VR, but most of the real tech they built was interactive story. It was later pursued in the Oz project at Carnegie Mellon, where he was a professor for a bit. And one of his PhD students, Peter Weyrauk, built the first implementation of this that came up with the plot point graphs, the DM actions, and like a little small kind of made up story world that he had come up with. And for years, actually, you could not get this PhD dissertation anywhere because, well, you could officially, but not digitally, because Joe Bates left CMU and started a startup company that was trying to commercialize some of this tech and sell it as middleware. It ended up failing, but Peter Weyrauk went and worked there after he graduated and sort of embargoed the thesis, which was an option you could have at a lot of engineering schools. And I believe the only copy you can now get on the internet is actually the one Professor Ware has on his website now, like for this course. I just looked for that Google Scholar. The only PDF that comes up is at uky.edu. So now you can get it on the internet, but you could not until like a few weeks ago, I guess. I have a hard physical copy that Michael Matthias requested from the CMU library. They have to give it to you in that case. And we started looking at it around 2004 to see if we could kind of plug this into bigger games like interactive fictions. And part of the reason I bring that up is because I think there's some like fundamental assumptions that actually go back to this 1992 paper that are not really explicitly stated or tested. And so this is from the 1992 paper. This game tree search analogy is kind of the argument for why take this approach. And this comes after discussing the concept of a high-level director as one component of his big system, which would have kind of like a low level of smart characters that are aware of the world, semantic objects, but then a high-level director that does things like plot arcs. And he asks, how can we view the relationship between the director and the user? One approach is to see them in a kind of two-player game such as chess. The director and user are taking turns, the user acting as free agents in the world, the director looking down from above and very gently pushing the elements of the world in various ways. The director is constantly trying to maximize the chances of a pleasing overall experience, no matter what the user does along the way. If we elaborate on the chess analogy, the pushes of the director and the actions of the user are the moves of the game. The director wins if the complete history of the world is consistent with the creator's aesthetic goals, thereby presumably pleasing the user. Now, there's a few minor changes here. So the player is not really assumed to be playing adversarially. We assume they're actually doing something kind of random from our perspective. Maybe even a little bit acting in our favor, depending on the kind of player. But this is kind of the basic setup. Is like in chess, you set up a goal like win, and then the director figures out using game tree search type techniques what to actually do to make this happen. And one of the arguments for this is that, well, you need some kind of way of setting up formally in kind of an AI sense, what is the director problem? And the other one is there's already all this investment in tech for game tree search, and the interactive story scene is much smaller. It was at the time, it still is. So if we could just use all this tech developed for game playing, it would be a win. We could just kind of drop it in. And that might still be true today. So at the time, like game tree search, alpha beta type search was the state of the art. Now you could use something like deep Q networks that people use for Atari game playing. You might be able to drop it in somewhere here. So at least if the formalism makes sense, there still is, I think, this argument of like off-the-shelf tech. But I'm not as sure about the analogy. I think there's still, it has some appeal, but it's a little bit slippery. So my thinking is that search-based drama management really depends on a global authoring hypothesis, which is that it's easier to write kind of these global conditions of what I want the overall experience to be than to write more local things like NPC behaviors using behavior trees or more local kinds of logic. I haven't looked into it a lot, but a few other DM systems also have this kind of, some version of a global authoring hypothesis, like some planning-based ones have the idea that you have these author goals, and you would delegate to the planner to actually make the, chain together sequences of decisions to achieve those goals. And this is kind of implicit in the game tree search analogy, but not really explicitly argued for, which is some of what I've been looking at. I have kind of a draft paper that I would hope to post as a preprint soon, analyzing this global authoring hypothesis and like to what extent is it a testable hypothesis? What do we know about it? It's kind of my current look at this. And so I read Bates as having an argument by analogy, at least implicitly. The starting point is specifying the win conditions of many games is relatively easy, like what is a winning move in a winning state in chess or Go. But making local decisions to reach those goals is much more complex. So like even chess opening theory can fill whole books, endgame theory also fills books, but like the win conditions of chess can be written down in not a lot of code. And therefore the idea is you specify overall goals and let some kind of AI system infer the local decisions. And the premise I'm seeing here is basically the authorial goals, like what an author wants an experience to be like, are like game win conditions, and the rest all follows. If that is true, we should write down what do we want. We want kind of like some kind of narrative coherence, maybe a plot arc, not too many red herrings. We just write down this like a list of desiderata, and then we tell the general manager to figure out how to make all this happen. The same way we say, hey, we want a position where we have the opponent in checkmate and we're not in checkmate, and then we figure out how to make that happen. So that's appealing in a way. And there's a little bit of evidence. This is some joint work with Cheryl Chen and Michael Matthias, where we tried to measure authorial leverage. And what we mean by authorial leverage is for each unit of global authoring, how much equivalent work of local authoring would we need to achieve similar results? So you could think of like leverage in the sense that we did a little bit of work here and then applied all kinds of this other work that we would have had to do manually. And I think this has some legs, but as I'll mention, I think has some issues as well. So this is me revisiting some of this work like 10 years later, trying to figure out like what did we actually learn and is there anything interesting to still do here? I think the answer is yes, but there's some thorny questions. And so the authorial leverage method we used was learn a decision tree that approximates the DM policy. And we thought of this as a proxy for hand-authored if-then style logic. Like the DM is making all these decisions at every decision point, but could you at each decision point have just written like a little bit of if-then type logic, maybe a state machine, and also got in like approximately followed a narrative arc? And so the size of decision trees that reach some predetermined threshold of performance, like 80% is good or something, is a numerical measure of leverage. We didn't look into it as much, but the number of edits needed when changing the eval function could also be another measure that authors often don't know upfront exactly what they want. And so if each time you change it, it actually implies all these kinds of non-local changes, that might be an argument that centralizing this authoring is a win, because it both kind of multiplies into large amounts of local decision making. And if you make one change, that it might imply like 50 changes you would have had to make manually at different sites to achieve the same result. And so we use kind of the decision tree size, which tended to be in these particular stories on the order of a few hundred nodes as a measure of the leverage you get. I'd say this is one of our more popular papers in this line of work because people like that there's this thorny like authoring problem, and this is okay, a numerical measure. There's a little risk though that like this is a numerical measure which people like, but do we just like it because it's a numerical measure and like we need something? Which is what I'm going to dig into a little bit. So the authorial leverage metric shows a win, but really only if the evaluation function actually specifies what we want. And this is not clear. It's writing experience evaluation functions is often a lot trickier than win conditions. Like what it means to win in chess is a little simpler than what it means to have a good interactive experience. Even what a good story is complicated. Even like what story does a particular author want is complicated. They don't necessarily know in a way that they can write down as a function that can be run. And then when you add in what you want from a good interactive experience, it gets even trickier. And so you can start deceptively simple, like it's easy to write a measure of plot arc, and it seems clear that it's a win to do that globally versus try to figure out what sets of local decisions just happen to always emerge into like the right plot arc. And so that I believe is true. But then we have some other goals, like we want some kind of story consistency. We want the DM not to railroad the player. So that like, if there's 5 different things that happen, it could just always pick like the exact thing that will like closest match the arc most closely. So since we don't want that, we add some other features to the evaluation function, like penalize interventions, some measures of like average branching factor for keep more choices open, don't close them all, and so on. And so in Anchorhead, for example, we made the evaluation function out of a weighted sum of features. So a bunch of different features, you give each of them a weight and then you sum them up. And for technical reasons, we made the sums always, story quality always between 0 and 1. So there's always sums to at most 1. And a few of them were, for example, activity flow. Prefer consecutive plot points in the same place. So we want some amount of coherence of activity there. Goal flow, so prefer consecutive plot points in service of the same player goal. This is partly in hopes that the player in their mind would kind of build up like I'm on a progression towards a goal here. Well, if there's 3 possible open goals and they keep randomly getting 1 for each of the 3, they might get lost. This is partly just authorial decisions, but we came up with these different features, each of which is just some code that runs over completed experiences again. So experience is completed. The evaluation function has access to the complete sequence of plot points and DM actions, and is just told to rate this story between 0 and 1. Or you could think of it as 0% and 100%. Suspense, so we prefer a specific suspense or tension arc, and there's various papers on how to measure suspense in games that you can leverage. We use something pretty simple, but there's a lot of sophisticated stuff you could plug in there. Plot mixing, so near the beginning, we prefer multiple subplots to be going, and plot homing near the end to narrow in on one particular one. We borrowed that from Wayrock. Momentum, prefer specific subsequences of plot points, like there's 2 things that you can specifically annotate that these pairs go nicely, like this builds on this well. We got that idea from The Sims 2, has a very simple drama management system, but one of the things it does implement is tries to prefer these like nice 1-2 punches that come off nicely. And choices. So this is one that turned out to be problematic. We prefer the player to have more choices early on, just measured as branching factors. So all else being equal, if the player has an average of 4 different plot points that could happen next, that is better than 3. So this is to keep it from trying to close things off too early. And there's some problems that arise. Sorry for the amount of text on this slide. I'm trying to think of better ways to visualize some of this. This is like a paper that's currently in draft, so I don't have as many nice visualizations as the published papers. But there's a few main problems. So these evaluation functions are often counterintuitive. Like you can understand each of these different features, but then how do you weight them? Like I want to give 5% weight to plot homing and like 15% to choices. What does that really mean? These features might themselves have completely different distributions. So the weighting, like an equal weight might not actually be an equal weight if they have like different tails and one is bimodal and one isn't. Like what is actually happening here is not often clear. And the real author preferences might actually be complicated, not a weighted linear sum. It might be more like, well, if things are going well in terms of the plot arc, then I prefer this. Otherwise, I prefer this first, and then secondarily prefer this. And like, can you actually shoehorn that into a weighted linear sum? And equally problematically, like any AI system, the DM will optimize exactly what you tell it to. There's a lot of famous examples of this, like a circuit design system that designed a circuit that like only works at a specific temperature by leveraging some kind of like nonlinear interaction between nearby transistors, which you don't actually want in the production system, but the simulator allowed it, so it invented that. In this case, one of the more problematic choices is measured by average branching factor. And the idea was to keep the DM from railroading the player, closing off each time it found like a bad branch, just deny it. Say, player can't do this, only take the better one. But it can actually cause the DM to railroad the player into more branchy parts of the plot point space. Since we're just saying like higher branching factor is good, if you think of like a decision point where the player can go towards ending 1 or ending 2, if it happened that you wrote more content for ending 2, so there's more like plot points that happen here, the DM will actually always close off ending 1 because it's not as branching. We've said more branchiness equals more player agency is good. So that's like the opposite of what we wanted. We wanted this to counteract the DM forcing the player somewhere, but it ends up causing it to force the player somewhere. Which means maybe you need some better calibrated measure of like actual important choices, not just number of plot points. But it's pretty tricky to come up with these in a way that doesn't get exploited counterintuitively. And so there's some open questions here. This is my last slide here, just kind of like what I'm thinking of currently is open work and haven't gotten that far on. How do we write these evaluation functions? So there's been some work by Dave Roberts and Serge Bott and a few others about 10 years ago that looked at, for example, maybe we don't want the authors to write evaluation functions at all. We just want to give them to give us like, say yes, no to example plot points, example stories, and try to learn something from that. We might need some kind of better formal framework. Is this like a bag of features that we weight the right way to write these evaluation functions? Could we give some kind of more scaffolding to make it easier to write evaluation functions? Or maybe just better editing, debug, viz tools. Like if you could easily sift through stories and their ratings, and then you could tweak things maybe in a more interactive way. There's also this question of measuring authorial leverage more solidly. So if I think of the global authoring hypothesis as key to SBDM, then authorial leverage is so far the only attempt I know of to actually directly test this hypothesis, that like writing global evaluation functions gives you a win over writing local logic in a more like reactive type of way, either hand-coded or using behavior trees or like a reactive planner or something like that. And I still think looking at the equivalencies between local and global policies that do similar things can be illuminating. But there's a little bit of circularity in showing that small global policies imply complex local policies, which is what we showed in that authorial leverage paper, because the reverse is probably also true. That if you wrote like really simple local policies, it probably implies a very complex global evaluation function because of a kind of the emergence of all these interactions. And if that's what you really wanted, then you could say global authoring is actually complicated, because to get this simple local behavior, you have to write this really complicated global evaluation function, and the reverse is also true. So if what we really wanted was this particular global evaluation function, this is good evidence, but it's hard to actually say what we really want, partly because this is an artistic domain. There isn't like a gold standard for what is a good story or a good experience that we can test. And even the author's goals can be amorphous and changing, that if you give them two different ways of authoring interactive fiction, there might be different kinds of stories they would write. And it's often not, there isn't like this necessarily upfront, like platonic ideal of a good experience that they want to write, and it's just the tool won't let them do it. Like what they want to write might depend on the tool and experience with the tool and actually playing through the stories. And so that's, I think, one of the big open questions here is, how do you get around this circularity of, in a way, each tool makes the things that are easy to write in that tool easy, but then how do we show that a particular authoring approach is a win without like a gold standard of this is like the correct thing we want to author. And then we could show that method A like gets us there faster and more reliably than method B. But we don't even have like a set of benchmarks of like, here are, as far as I know, like here are 5 typical common but tricky authoring scenarios, and this approach solves them well. We have a handful of examples from various papers that may be more or less compelling. But that's kind of my takeaway of the big question here is there something we can measure about global authoring? And some of it is the evaluation function writing, and some is kind of just the general, like, how do we compare local and global authoring? And if we could show that, then I think it would be worth investigating more, actually plugging this into maybe interactive, like graphical 3D games, something other than text adventures, or text adventures also remain interesting. And then working on kind of like the tech of the connection there is also interesting, but I think like this in a way is like the key hypothesis that hasn't been shown yet. So that's why I've been focusing on it a little bit. I think that's about it for my overview here.
That was really helpful. Thank you. Yeah, I mean, just nice to have your reflections and reinterpretation of this work that we read a few days ago. Okay, let's open it up for questions. I've got a ton of questions as always, but I want to open it up to student audience first. Maybe while people are thinking of questions, I'll just throw in one or two. One is, I guess, more just a suggestion. We did some work on something like this a couple years back where we had this giant graph and we ran into the similar issue of trying to measure like quality of an experience. And instead of using branching factor, we use number of accessible endings. So which may I don't know if you tried that or if you have thoughts on using that as like how many endings are still available from this moment in the story.
Yes, in Anchorhead we had some version of that. It was more that all of the endings should still be available up until some amount of time. So it was more of like a don't close off endings until a certain point of time. We had borrowed the choices metric from Wayrock, I think, as just like a more generic, and all else being equal. In addition to that, we just like more options available. But we ran into this kind of like a issue of all else being equal is assumes like equal branchiness of the graph in all parts of the world. And real story graphs are very weird looking. They're not, they don't even look as nice as I feel like a typical game graph looks, like a Go search tree or something. Actually, a nice a little anecdote I was meaning to throw in but forgot about is, so we got the actual source code from Form 6 for this Anchorhead game just by emailing him and like saying, hey, we want to do some interactive narrative research. Do you want to send it to us? And then like a year later, I got an email from Michael Janessaris saying, this is a little bit embarrassing, but do you have that source code I sent you because I lost it and can't find my backup? And fortunately I did, so I was able to give him his source code back. So it's like a plus of sharing with researchers is they might keep your source code around.
Oh, that's great. I love that. Yeah, and so just sort of to confirm also something that you said, something that came up in our discussion when we were discussing the DODM paper was the difficulty of using something like reinforcement learning, because this is phrased as like a non-Markovian process, because you have not only the current state, but you also need to know the entire history that you've made up until that point. But I guess that's kind of, you're sort of avoiding that problem by saying your function only runs at the end. Like you assume that the whole experience is over and you only measure the quality of it after the whole thing is finished.
Yeah, so there's kind of two things for that. We don't do any static evaluations. We run only to the end. It originally used some kind of sampling search. Wayroute, because you couldn't do full game tree search, he used a little, it would stop at a certain time and then start taking a certain number of samples, which you could think of as like a kind of ad hoc precursor to something like MCTS, which maybe is a more principled way of doing that nowadays, but didn't exist in 1997, or wasn't well known at least when he was doing that. But also we just wrap anything important about the history into the states. So that's kind of like a typical hack for making something MDP is you just put the history into the states. It really multiplies your state space, but it's just Booleans of has plot point 1 happened, has plot point 2 happened, etc. And so that gets
Yeah, and I just wondered if you had thoughts on how sustainable that is. Like, as you say, yeah, you can do that. And great, you've transformed a problem where you care about history into a Markovian problem, but at the cost of massively increasing your state space. And I don't know, is it worth it? Is that scalability going to be a problem for you?
That's a good question. My feel at the current scale is no, because by the standards of like modern like deep Q networks or something, we're looking at tiny problems. So like this Anchorhead plot point graph has 30 plot points. Even if you multiply the state space, we're not talking about StarCraft 2 levels of complexity here. So I think existing tech can kind of like crush the technical side of it. It's more the authoring side that I think still is a big open question. Like, is this the right, if you could author in terms of evaluation functions over plot point sequences, I think the tech exists to then optimize that. But is the result what you actually want?
Yeah. How do you feel? So and this is I'm afraid that this question is going to be interpreted as an overly harsh criticism, which it's not meant to be. All of us are working in small domains because that's what we sort of have to be working on, especially for these prototype systems. But like the Anchorhead plot graph is small enough that a human could reasonably do that task for it. Like you could just hand author a pretty decent drama manager for a graph that small.
Yeah.
The idea is that we want this technology to apply once the graph scales past what a human could reasonably do by hand. Is that right? Would you agree with that motivation? Or
I think so, yeah. I mean, I think it's a little bit of an open question whether you could easily handwrite the Anchorhead graph, because there's only 30 plot points or so, but there's a lot of different possibilities. So our attempt to show in that authorial leverage paper is that even in that case, like the equivalent decision trees are pretty big. Now there are more compact ways of manually authoring policies, like using behavior trees or state machines, which in a lot of cases are more compact than like a bunch of if-then script and trigger type logic. But yeah, I think I would want it to scale bigger. And in a way, I mean, like, as you were saying, it's a common problem is we want to work in toy domains because they're kind of understandable. The attempt to use Anchorhead was an attempt to at least start from like a real interactive fiction that real humans had played. And I think you could build a bigger plot graph into that. I pulled out 30 plot points. You could pull them out at a bigger granularity. Because some of the previous stuff studied, like Wayroute could use a little made up T for 3 story, which has like 12 plot points. And it was created specifically for that research, which has pros and cons. And we had, for just some of the computational experiments, a game called Alphabet City, where like agents move on like a little grid world between different houses. But yeah, there's kind of like the scaling question. I still feel like scaling the authoring is a bigger problem than scaling the tech at this point. Just like manually constructing that plot point graph for a bigger story would be a problem, unless you somehow wrote in a way that was automatically extractable. It might also depend on what kind of scale we're talking about. If it's a really big game development project and they happen to find an approach like this useful, that might be a relatively small task compared to, you know, making all the 3D models in a big game. But for an individual researcher, it's a bigger problem. And in a way, like validating that it actually captures what happens in the real game. Because the pro and con of that is we're saying the drama manager doesn't actually have to know what's happening inside of Unity or Inform. But if you gave them this high-level map that is not consistent with what's happening in the game, it's going to make decisions just like based on what you were told it.
Great. Okay. I want to stop hogging all the question and discussion time.
Yeah. I have a kind of general question. When you're working on a problem like this that can take years to work on, is there ever like, how do you adjust for the fact that tech can increase at a rate where maybe some of your limitations at the start of the problem are obsolete by the time you get to the end of it?
Yeah, that could definitely happen. It didn't feel at the time like this happened to us, but I don't know, whatever particularly was happening in the period 2005 to 2009 didn't result in that. Some of it has been that you just have to periodically revisit. So there are things that were a problem in this 2005 paper that I haven't tried. My guess is you could throw a modern reinforcement learning algorithm at it and it will converge in like 10 minutes or something if you have GPUs. But some is here we were focusing on problems that seem more intractable in a way, like the authoring problem, as far as I know, hasn't had huge tech advances in the last 15 years. Although there's certainly more approaches to it than there were 15 years ago. And I personally have a research strategy of somehow trying not to do exactly the cutting edge work everyone else is doing, partly just out of practicality. Like I don't have a big group with PhD students. American University is kind of like it's called an R2, like it is a research university, but not the top level of research intensive university. So I pick problems where I don't feel like I could be scooped by MIT or Stanford or something because they're just not working on the same problems, which I mean, there's pros and cons to that, but I think there's an advantage actually for that, just as a general research strategy. If you want to get into a top tier conference like AAAI, not working on like exactly the same problems that they will see 500 submissions from is a little bit of a plus. So if you're trying to increase the current state of the art in like large GPT style language models or ImageNet or something like that, you have hundreds of papers of competition and much less so in some other areas.
Yeah, good practical advice.
Which actually we're seeing for, I mean, like student applications too, that if you want to research literally anything except like certain very hot areas of deep neural networks, you will have a much better chance of getting into a good grad school because there's like 5,000 applicants for one and many fewer applicants for the rest. And we're not all deep neural network researchers.
Yeah, that makes a lot of sense.
Yeah, like Luke, so everyone here has had some experience, even if only in like tabletop role-playing games, of doing drama management. Luke, I know you've done some drama management work specifically with Dr. Harrison. I don't know, what were your thoughts on attempting to write some function to measure quality? What problems did you run into or insights did you have?
I haven't in my work done any attempt to measure quality, but I like looking through my research, I always found those the more interesting and important. I always thought that it was important to measure the quality of the actions being taken. And I was curious if like more specificity could go into like how quality was defined by the authors of was it an authorial thing or was it more of an algorithmic decision?
And do you have, Luke, tell me if this is right. Are you working on a drama management system for like one night, Haunting on the House on the Hill. I can't
Yeah.
remember the exact name of that game.
Yeah, I'm
Yeah.
working on a system for Betrayal at the House on the Hill.
That's right. Great. Do you have any sort of overriding theory for what distinguishes a good experience versus a bad one while playing that game?
So the main intuition I've been relying on is just case-based. So the goal is that at the end of the game, the players would record their experiences, and then the drama manager would navigate the better experiences and try and keep things within that realm of positive experiences. So I'm basically just trying to trim out any of the like unenjoyable experiences that can occur in that game where you don't have the necessary requirements when you reach the haunt, or someone who doesn't want to be the traitor becomes the traitor. So I'm not doing a whole lot of like optimization. I'm mostly just doing like trimming and pruning of bad spaces, if that makes sense.
Yeah, it raises the question, Mark. I don't know if you would reflect on this, the idea of like, often authors go in with some idea of what they want, but then translating those ideas into an evaluation function can be a real challenge.
Yes.
I wonder if there's some opportunity for like a debugging tool, like a thing that says, okay, here's what I think I want. And then it gives you a bunch of samples and you say, oh, I didn't actually want this. And it sort of helps you refine your function.
Yeah, I think something like that would be very useful. Like even if you stuck with a model of linear combinations of features, maybe learn the weights instead of from examples, instead of asking the author to give them. There's kind of an interesting question of whether the components that we're weighting are good also, that which I'm kind of interested in kind of as like a sideline in this like really formal narratological theory. There's people who try to write like theories of what foreshadowing in literature means. And if you did have like a big toolbox of like really nicely formalized ideas that you could give to the author, maybe we could learn those. At the moment, we have very simple things mostly. I think there's some fairly complicated models. Like I think Young Chung, who's one of Michael Young's students, had a formal theory of suspense, which is fairly sophisticated. And so if we had like a big toolbox of these, I kind of like the idea of trying to learn like this formal model of like good experience according to some definition of good experience. But I definitely agree that it's not likely authors are going to be able to manually write anything very complicated. So something like that interactive model sounds better to me.
Or if they could, it's highly unlikely it would be right the
Yeah.
first time. It would definitely need tweaking. Yeah. Yeah, and that's interesting because a system that sort of samples and gets feedback is sort of like, yes, this was good, no, this wasn't, could maybe even also tell you, hey, none of your features are good. Like you don't have the features here.
Yeah, like this, there's no way to weight these features that produces the results you want. So you must have some other preference not captured by our like set of theories here. Yeah, that's an interesting approach too.
I had a quick question. You mentioned ways for measuring tension, and you said that there were existing methods. Do you think you could point me towards what those are so I could look into those, or you could talk about them?
Yeah, it's not really my area, so I haven't looked in much detail. I just know that I think they're more planning-based models, which maybe Dr. Ware knows about, of like, how do you formalize the concept of like tension in a game?
Yeah, the one I know of specifically was suspense, and that you mentioned, and that one was based on number of perceivable ways you could achieve the goal. So that model of suspense was based on like, oh, the protagonist is in a situation, and the number of different solutions that the audience can imagine corresponds to suspense. So as you're like more actions are happening that are cutting off potential solutions that the protagonist has to get out of their problem. And once that goes down to either like to very few or even zero, then that's sort of like increasing the tension and feeling of suspense.
That makes sense.
Oh, okay, that's interesting.
Now I'm thinking of like Facade had a model of kind of like, I don't know if they call it tension, or it's more like essentially uncomfortableness of the situation. And that was more written hand authored for each local thing, that when Grace brings up like a particular marriage problem, that now increases the awkwardness of the situation, and there's just some number attached. So when you want to up that, you pick one of the high valued next actions available.
Yeah, and that's interesting because it sort of gets at the idea that some some features can be authored like that. Like you can reliably say like this event directly increases awkwardness, and you can feel pretty confident in that.
Yeah, like in any situation that you bring this up, it's going to be awkward.
Right. But a lot of the narrative features we want to talk about are things that can't be predicted based on the part of just one event, like suspense. You can't say this one event is going to make it more suspenseful, because that's always in relation to endings or previous events. And so those are the, like, and a lot of authors want to talk about sequences or relationships between events, but that suddenly makes it harder or impossible to author those values on a per event basis.
Yeah, I think I agree with that. Yeah, it's kind of like things that in some way fundamentally depend on longer stretches, especially like long distance, like things that might be in a large game over a period of hours or something, not little sequences. And I think that's what drives people towards wanting some of these more global models, either search-based drama management or more planning-based systems. The idea that we do want kind of like this big story level quantities, but then how do you tie that into the more practical, like what specifically should happen here kind of decision making?
Yeah, it also raises another sort of, I don't know, technical hurdle to come over, which is one of the, yeah, we have sampling based methods like Monte Carlo tree search or something like reinforcement learning, which sort of degrades gracefully, like you just train it as long as you can and you'll get some improvement in your drama management, even if you don't get a really good one. But the problem is when you start measuring things in terms of these long sequences of events, then you're going to have a really sparse representation. Like you're going to have, there are so many possible combinations of events that even if you sample 10,000 things, that's only a very small sample of your space.
Yeah, that's definitely true. And yeah, so early on we had some assumption that just search was not scaling to something even the size of Anchorhead. But then later when we applied some offline reinforcement learning, we found it really, like what we thought was the optimal thing it converged to was really not that high a score either. And our then later hypothesis was just the particular combinations of like interventions the DM had didn't allow it to, like the optimal story basically was no higher than 0.6 out of 1 or something like that. And that's just a limitation of the particular combination of the graph, how you defined your evaluation function, what inputs it had, because you have these different trade-offs, like I could intervene, but that I get a little penalty for that also. But yeah, for certainly a much longer story, I think you would have problems doing these search-based methods. It's something like Monte Carlo tree search doesn't scale well to like 1,000-length sequences, as people found on games like Atari.
Yeah. Great. Well, thank you so much for sharing your insights and speculation. I'm really excited about this future work. I love this idea of trying to measure or justify the global versus local authoring question. That's really interesting, and I can't wait to read your next paper.
Great. Yeah, I hope that this actually motivated me a little bit to like look back at this paper draft that's been languishing and say, okay, I should actually like polish this up. And it's kind of like trying to do a post-mortem of this work I did for about 5 years, but focused on something specific rather than like a survey paper recounting here's what we did for these 5 years.
Sure.
But yeah, thanks a lot for inviting me. And
yeah, thank you so much for coming, Mark. I really appreciate it.